SketchUp is the perfect tool to model geometry for Mold Simulator. Enabling X-ray makes it easier to inspect the mesh. Note how this mesh satisfies the geometric criteria required by Mold Simulator. See the documentation for details. This model uses meters as units and was exported to 3 deciseconds format with default export options. In Mold Simulator, we need to set a couple of parameters before importing it. We need to swap the Y and Z axes, and a scale must be set to 39.37 comma, since SketchUp internally works with inches. The mesh has been properly imported. We can also check its size, which should be 1 meter. A mesh is composed of several volumes. Click on them to select them. The 3D outliner is vital with imported meshes. Open it from the View menu or by double-clicking on a volume. When it is open and the L next to Wireframe Unselected is active, every volume except the selected one is displayed in wireframe. The L next to Hide Unselected works the same way. Materials can be assigned to volumes just like in 2D, that is with the Fill tool. We can also first select a volume and then assign a library's material to it. Here we have 2 concrete layers with a steel bar inside. Now, it's time to assign boundary conditions. Double-clicking on a surface assigns the same boundary condition to the whole coplanar surface. Now, we're ready to perform the simulation. Note how the bars changed the concrete thermal performance. Highlight temperature variation by changing the displayed temperature range. We'll use the internal boundary minimum and maximum temperatures. Now let's check temperatures and flows inside the mesh too. Sampling analysis is very handy here. First, we create an area section element. Then we activate temperature and flow sampling. Both are active on flows simulation only, since we're not simulating condensation. Now we move the section element to the middle of the mesh. Hold the Z key to limit movement along its Z-axis. Sampling analysis is computed on the fly. Let's tweak rendering settings to make it more prominent. Same for heat flow. Now let's see what happens if the steel bar is heated. Make sure the A button is active. Then we select the bar and add some heat flow to it. We need to run the simulation again. Sampling analysis is very helpful in this situation too. We can also use isotherms to highlight the heat from the steel bar. Let's hide sampling analysis and remove transparency on temperatures. Now we just need to apply a custom range to the isotherms sequence. The effect of the heated bar is evident on flow visualization too.